my name is Amaya Bragg.
And I'm Katie Dunn.
And we've been researching host selection of the green flight orchid at Alapaha River Wildlife Management Area under the mentorship of Dr. Jason Scott. Green flight orchid, Epidendrum calypsium, is an epiphytic species, meaning it occurs on trees. The trees on which it occurs on are referred to as sporophytes. The green flight orchid is unique that it holds the distinction of being the only member of its genus to occur north of Florida. Many other members of this genus occur in more tropical regions, and the green flight orchid occurs in more temperate regions such as South Georgia, Florida, and into the coastal plains of South and North Carolina. This is most likely due to their relationship with their specific host species. Bertram and Carter in 2008 found that green flight orchids typically prefer southern magnolia, Magnolia grandiflora, as well as live oak, Quercus virginiana, as the preferred host. However, sporophyte selection is not solely based on species. There are several other factors such as moisture retention, seasonal leaf abscission, as well as bark characteristics like texture and chemistry that play a role into whether or not a green flight orchid is able to establish on a given host. There are many habitats that the green flight orchid can occur on, such as lithophytically on sandstone outcroppings, which means it grows on rocks, as well as near streams and rivers and lakes, and as well as oak hammocks. Oak hammocks are a wetland type that are characterized by being raised and surrounded by other wetlands and have dense hardwood overstory. Southern magnolia and live oak are very abundant within these habitat types and have a canopy cover that can give the green flight orchid the proper moisture and humidity that they need to be able to survive through cold winter months. Unfortunately, the oak hammocks are becoming relatively rare because of agricultural development in past years, which have scattered remnants of this habitat type throughout the landscape. Other factors such as plantation forestry, urban development, as well as roads and other wetlands further separate all these habitat types, and this has caused populations of the green flight orchid to be small and fragmented. So to better understand the green flight orchid, we want to know more about their natural history in the more inland portion of the range, which we are in. And to do that, we want to look at host species selectivity as well as how each individual colony grows on the host tree.
Our study area was Alapaha River Wildlife Management Area located in Irwin County, Georgia. This property is currently owned by Georgia Department of Natural Resources and is roughly 7,000 acres. And of those 7,000 acres, 24% are classified as wetlands. This property was previously owned by private landowners who used the upland sites as row crop agriculture. In 1960, it was sold to Rainier, a timber company, who converted the old ag fields into pine plantation. To begin our methods, we created a map using ArcGIS Pro, where we selected 4 wetland types that would support our suitable habitat for the orchid, which allowed us to exclude artificial duck impoundments as well as beaver dams. The wetland types that we did choose were oak hammocks, river floodplains, bay swamp, and creek swamp. And of those wetland types that we chose, we placed 5 randomized points within each, totaling the 20 points. With those points, we had created a 100-meter radius buffer around each point to constrain our search. Once the map was finalized, we uploaded it into Avenza Maps, where this allowed us to have easy navigation into the field, as well as having a visual representation of the transects that we will be surveying. Once an orchid was found on a transect, we marked in each host tree with GPS coordinates as well as flagging. After the entire buffer area was surveyed, we went back to the location of each tree to record the host species, the diameter at breast height, the colony height, as well as the number of clusters on each tree. We define a cluster as overlapping roots of an orchid. And to estimate how many trees available and were available in each buffer zone, we used variable radius plot sampling. We chose this sampling type due to its bias against large trees, or large trees. And we hypothesized that the orchid would prefer a larger diameter of trees. We placed 4 points within each buffer, one at each cardinal direction, 50 meters away from the center plot. We used a 15 basal area factor wedged prism to classify what trees were in, and we recorded the species and the DBH of each tree.
So to analyze our data, we did a two-tailed t-test to determine if there was a difference between the diameters of the available southern magnolias within the stand compared to the southern magnolias that were being selected for as host by the greenfly orchid. We did this with an alpha value of 0.05. We also did a selectivity index that was originally modeled for fish habitats, but then later modified by Bergstrom and Carter, specifically for the selectivity of greenfly orchid. The equation goes as follows: host species plus available species divided by host species minus available species. Overall, we found the greenfly orchid occurring within 2 of our plots. These plots were found in the same 1.5 hectare oak hammock, so we decided to combine these points. But we also decided to combine these points because we did have such a small sample size. We found in total 11 host trees, and 10 of those were southern magnolia, whereas 1 was a water oak. On 3 different occasions, we found the greenfly orchid occurring terrestrially beneath a host species. Although this is unusual, it is most likely due to a branch falling off of the host tree, and then as the branch decomposes, the correct requirements for a greenfly orchid to exist were still present, and the greenfly orchid was able to persist in the soil column without being on the host tree. On the actual host trees, greenfly orchids were typically 6.7 meters off of the ground, and they range from anywhere from 1 meter off the ground all the way to 12 meters off the ground. And there was about 8 patches per tree. Our t-test found that there was no significant difference between the diameters of the available trees and the host trees. This could be due to such a small sample size, as we were not able to sample a lot of trees because the area was so small. So to do our selectivity index, we needed to find relative frequency, and we needed to find relative importance by basal area. So relative frequency is just how frequently each species occurs within a stand. So to find this, we divide the total number of host trees with total number of trees within the stand and divide that by each individual species. For example, if we have 45 total trees and you divide that by 13, you will get 0.29, which is our value for the loblolly pine. As you can see, loblolly pine, southern magnolia, and water oak are the 3 most prevalent trees within this stand. As you can see, greenfly orchid is selected for southern magnolia 90% of the time, which is a lot more than expected for random use. You may see that loblolly pine is comprising most of the stand and may be wondering, if it's so prevalent, why is it not being selected for? Well, this is most likely due to the fact that the loblolly pine has a more acidic bark. And because of this acidity, the mycorrhizal fungi that is needed for a greenfly orchid to exist on a tree is not present, as it is not able to co-inhabit on this loblolly pine. Here we have relative importance by basal area. We calculated this the same way, with getting the total basal area of the stand and dividing this by each individual species. You can see loblolly pine, southern magnolia, and lower oak are the 3 most common species on the stand. So to get a better understanding of what this means, Think of it in terms of a target. Say you have a really large target and you throw a dart at it. You are more likely to hit that target, right? And say you have a really small target and you throw a dart at it. There's more of a chance that you're not going to be able to hit it. This is the same thing as we are trying to describe with the basal area. See, southern magnolia takes up a lot more basal area within the stand, so it's more likely for a green flight orchid seed to be able to land on the bark of the tree and exist. And you can see American holly has a very small value there, and it is a species that green flight orchid has been documented on, not within our stand, of course, but it is such a small basal area that it's not very likely for the green flight orchid to be able to establish there because it's such a small area. So here we have our selectivity index. Our selectivity index can range from 1, meaning perfect selection, to -1, meaning perfect avoidance. Although we use the term avoidance, this does not necessarily mean that the orchid cannot occur on here. It just means that it does not favor it as much. We have N for our sample size, SI subscript S for species, and SI subscript B for basal area. You can see we have positive values for both sections for southern magnolia, and then we have negative values for water oak for both of these, which means that the green flight orchid selects for southern magnolia and avoids water oak, which is consistent with a previous study by Bertram and Carter in 2008. So with such a small with such a small population size, this can have serious implications for this population, as it leads it to be more vulnerable to extirpation. According to the principles of island biogeography by Wharton, the more small and more isolated a species is, the less likely it is to be able to recolonize. Say a stochastic weather event such as Hurricane Helene were to come and wipe out some of these host trees. This would prevent the green flight orchid from being able to recolonize as successfully as there's less individuals. So to combat this, we recommend that we continue monitoring the population to ensure that the population is increasing or at least staying the same, and to take extra precautions when doing management around this specific site to reduce the chance of fire or any other mishaps to occur within the stand and would damage this population.
We would like to take time to acknowledge and thank the Department of Forest Resources, Dr. Jason Scott, Dr. David Bragg, and Dr. Ross Weiss III. Questions?
Originally, there was several other study areas that we were hoping to look at. However, there was many complications with this. One being Hurricane Helene actually destroyed one of our study sites that we were hoping to look at. Another one was some property managers, some private property managers. It was hunting season when we were trying to conduct the study, and of course we didn't want to impede on any hunting, so we were not able to go onto those properties, or maybe we weren't even able to get a message back. They are. It's very smooth bark that doesn't exfoliate. I'm not sure. I can't remember it was found in the other study site, but it probably is a very suitable species for green flight orchid. We actually used binoculars and made sure it was decently bright outside. We would actually use binoculars and we walk around the tree, and it's not very common for a green flight orchid to occur on a branch where there's a lot of foliage. It would mainly occur on the trunk of the stem, so we don't believe that there's any detection issues or probabilities with that.